Hello, in this video, we will use Google Sheet LINEST function to perform the logistic logarithmic regression analysis. We will use logarithmic, so the equation of y will be in the form of b0 plus b1 ln x, where we factor out 1 plus ln x from the equation and leave behind b0 plus b1. So we begin with the chart, the scatter chart, and show the equation, the logarithmic equation, as labels. So choose the scatter chart, and the logarithmic equation the trend line will be logarithmic, and show this label, and also r squared. So our equation now is in the form of y equals 0.0748 plus 0.488 ln x, and our value of r squared is 0.374. We will use Linus equation or the Linus function, but before we do that, we have to convert the x value into the ln x form. So we need the 1 and ln x matrix. So we begin with the 1 column, followed by the ln x column, which is array formula. ln x, ln of the x values. Now that we have the ln x matrix, we can now enter the LINEST function, LINEST of data y, data x, or data x will be ln x, and we show the full statistics. So our b0 is 0.0747, which matches our chart, which is 0.0748, which is rounded off. Our b1 is 0.4884, which is 0.488 ln x, so this is rounded off. Our r squared is 0.373736, which is rounded off as 0.374. We can now calculate the b1 by using the slope formula, which is data y and data x. Our data x will be ln x. So our slope is 0.4884, matches to our LINEST output. Our intercept will be again using the intercept function, data y, and data x will be ln x. So it's 0.0747, matches to our LINEST output. Our r squared is RSQ of data y and data x. 0.3737 matches to our LINEST output and our chart, which is 0.374. Our stay x will be stay x, data y, and data x will be ln x. 0.417 matches to our LINEST output. Then we calculate for the rows or the population, which is rows of the dataset range, which is this one, this area. We have the population of 18. We can now calculate the regression sample square, which is equal to RSQ times N times VARP, VARP, or variance population, of the Y values, which is 1.661, matches to our LINEST output. Then our RSS, our degrees of freedom of denominator, will be rows minus column, which is equal to rows minus columns of the dataset range, and that's 16. Now we can calculate for the residual sum of square, which is degrees of freedom times stay x squared to the power 2. which is 2.78339, matches to our LINEST output. Now we'll calculate for the F statistics, where we have the numerator making up ESS, or regression sum squared, divided by degree of freedom of the numerator, which is 1, because we only have one independent variable. The denominator part will be RSS, or residual sum of squares, divided by the degree of freedom of the denominator. And it is 9.5483, matches to our LINEST output. Now we can calculate the standard error values of the coefficients. But before we do that, we enter or calculate the Picciorina inverse matrix, which is minverse and multi transpose of the 1x matrix and itself. Now that we have the Picciorina inverse matrix, we can now calculate for the standard error value of the coefficient B0, which is stay x times square root of Picciorina red. And this matches to our LINEST output. Then we calculate for the standard error value of B1, which is again stay x times square root of Picciorina blue, which is 0.158, matches to our LINEST output.